What did you calculus one? Folks, you must know your antiderivative very well. If you want to do this, there are many ways to do this. One way is just to say, well, there's 2 pi times this. That is to say, find this and multiply by 2 pi. Or if you want, you can make it part of your function and find its antiderivative. You know, the antiderivative of a constant times the function is a constant times the antiderivative. That is to say, what is the antiderivative of this? Well, the antiderivative of this is the constant times the antiderivative of that, being x to the 4 over 4. Evaluated at 5, evaluated at 2. Now you have to put the 5 into that function, put the 2 into that function, and good. Are you with me? Good. You must know your calculus 1 in and out. Okay? Constants and all those things with antiderivatives and evaluating definite integrals. You must be an expert at it. You must not get your signs messed up. Your SIGNS. Your constants and things floating about with the 2 in front and the pi in front. You should say, I'm not afraid of it. It's a constant. Why? You don't know. The antiderivative of this. C times the antiderivative of F. Did you have a good calculus 1 professor, Mr. Harris? Did he tell you this? You did, huh?
I don't recall.
Oh, he told me this. He most certainly did. Oh, you must be good at your antiderivative. You must be an expert at definite integrals. Okay? You must have no trouble with definite integrals. So I'm going to set a problem and say, hey, that's a definite integral. Give it to your calculus 1 friend now. I'm not going to do it. I'm not in the definite integral business. The definite integral business is calculus 1. I'm sorry. My problem is to set it up. It's a definite integral. This definite integral gives you the exact volume. When you take the function, the area under the function f of x between a and b and rotate it about the y-axis. This definite integral will give you the exact volume. It is now your duty to evaluate that definite integral. Mr. Collas, do you have any qualms with that expectation? You're going to see more definite integrals in a minute. Nothing but definite integrals. Everything is definite integrals. What's this? This is the length of a curve. Happens to be a definite integral. What's this? The amount of work to take to lift this thing up. It's a definite integral. You can go and look at physics. Everything is the integrals, the derivatives. You are wanting to find the exact work to take this thing and lift it up here. So from here to here, you're going to have to integrate. Everybody get 6 pi? Miss Heather? Huh?
I'm not finished.
Oh, okay, go ahead and finish it.
I was like, oh.
Yeah.
For substitution, maybe.
Oh, Miss Harris, I'm going to ask you that. Mr. Harris?
Even if you did that, then it would still get used to one.
Yeah, exactly.
You're like, oh, what is that even? Substituting.
Yeah.
What did you get, Mr.
It's
Collins?
only math exactly.
Yesterday? 6 pi?
On the second quiz, there's like limit C has, it was like L and dx. So I took the derivative and then started calculating all the transitive.
All that's too much work. I used to be able to do stuff like that. Now I just.
Okay, so what we're gonna do is, you're gonna have this curve 1 over x between, what? Between 2 and 5. You're gonna rotate it this way. Picking up another volcano. So your volume is 2 x times f of x dx. What is f of x here? X times 1 over x dx. And what is x times 1 over x? Tell us. X times 1 over x. 1. Thank you. Well, now that one is easy. What's the antiderivative of 1 dx? Correct. You take the x, you evaluate at 5, take the x, evaluate at 2, subtract, and multiply by 2pi. Like Mr. Harris. Oh. Okay. What's next? Miss Holt. What's next?
More fun with calculus. Starring.
Well, what we want to do now is we want to do the same thing, but we now want to take the area between two curves and rotate it.
Oh, beautiful. Hold on, I gotta pick up pieces of my mind real quick.
So here is an example. You would have a function f of x. Let's assume that's one on the top. Then you have a function g of x. That one will be on the bottom. You're going to take that between a and b and rotate it this way. And you're going to create a volume. How would you do it?
I mean, the way I saw the other problem is the x was kind of like, what is it, kind of like the base, and then the f of x is the height. So you can do x, and then open parentheses, f of x minus g of x, close parentheses.
Yeah, so what you're saying is, why don't you take this curve here, rotate it about the y-axis, find its volume, rotate this curve here about the y-axis, find its volume, and
Wow,
that's what we have to do.
that's pretty simple.
It's much simpler than trying to say, what's the formula for it? 2 pi f of x, x times minus g of x. No, you subtract the integrals. Right? Okay? Yes, you subtract the integrals. Just set up the big integral, set up the small integral, and subtract. Of course, you have to know, Mr. Boji, you will have to know which function is on top of which. Otherwise, you will get negative. Right? You must know which one's on top of which. So I'm assuming f is on top of g. And of course, I'm assuming you know how to find a and b. Is that a safe assumption, Ms. Yasmina? Thank you. So you will take your big volume. That would be your big volume would be this. Big volume. And then your little volume would be that. The big volume would be rotating that. And then your little volume would be taking that. You would subtract. That is to say, integrate the top function. Take f of x dx. And integrate the bottom function. Mr. Boji, you better know which one's on top of which. Okay, so I was busy with this. I think let's do this. Let's do an example.
I think you said it was around x equals y equals 1. y equals x.
I was thinking, yeah, y equals negative x.
That's probably that. Wait. Maybe we can definitely like we have a function like that.
So you have these two curves, y equals 7x squared. Y equals 7 root x. And you're going to look at the area trapped between that and rotate it about the y-axis and find its volume. You will have to make a sketch.
That was the first one.
So you will graph 7x squared is like x squared that's stretched